I tend to run around a lot, so if I'm close to the edge, please someone stop me because it looks hazardous because I might run off. Hi everyone. My name is Johnny, as said here, and also as said, I work as a solution architect. So I'll be talking today around containers. Before we begin, how many saw the keynote or one of the keynotes of Max? Okay, good, because I think that's pretty interesting, actually. I always start with the why, so I got asked to do technical presentations, so we'll get to technical, but I want to cover a bit of the why also to provide some context. And when I go out and talk about OpenShift and containers in general, I basically always start with this slide. So this was a guy called, well, you can read his name there, right? He wrote an article for Harvard Business Review 2003, where he stated IT doesn't matter, right? So this is kind of like what's happened through the years. And what he meant was that there is no strategic value in IT. I cannot use it to be different or to compete in the marketplace. Strange, huh? So a couple of years later, another person comes out and says something entirely different, right? Everybody is now a technology company. And to kind of like complete the circle, finally HBR publishes yet another article basically saying that everyone is now a software company. So what has caused this change or this changing role of IT? And Max, before here, he talked about a couple of few companies, right? We know these companies around the software disrupts business, and it's the Ubers and the Airbnbs and whatnot. I'm not going to talk about those. Those are interesting examples, all of them. But I like to take more basic examples or simpler examples, which is closer to me. So a while back ago, I was watching TV, and there was this commercial on Oral-B Brown Control electric toothbrush. Everybody heard of that? Cool. So there was a commercial that you can now download an app to talk to your toothbrush. Can you see the greatness of this? I'm like, oh my God, I have to go out and find a new toothbrush. Well, obviously, does anybody get it? I didn't. I was sitting there like scratching my head and saying, yeah, I don't get it. And a couple of weeks later, I was out drinking a beer, and yes, I have to admit that this is a topic that I frequently discuss on my free time as well. And I was having a conversation with a friend of mine. It's a very strange commercial the other day with, Oral-B Brown Control. You can now download an SDK, a software development kit for your toothbrush. Wow. And he said, well, it's actually pretty amazing. I was like, what? How do you mean? Well, they've created an app together with Disney. And he says, I have a daughter, which when it's time for toothbrushing time at the evening, it is a struggle. Anyone with kids in here? So apparently, brushing the teeth at night or evening is it's like a struggle. It's a war, basically. But they've created this user experience of the toothbrush where she can actually, as long as the SDK notices that the toothbrush is brushing, she gets to watch her favorite episode of Frost. So Oral-B Brown Control has used IT and software as a service to provide a fabulous user experience for the 9 or 8-year-old while brushing their teeth. Maybe she's younger, I don't really know. So this is what we're seeing, right? And this is kind of like someone's doing something new. Talk about innovation, right? And this is what's happening, right? Someone goes out with something and it becomes the new norm. Once iPhone came out, that was the new norm for all of the software that was connected to the phone. Once Netflix started streaming videos, there was a lot of other companies that were trying to do the same thing. And it's about this copying or using software together with your product that is this how people want to use software together. And this is popularly called the kind of like the business, the digital transformation. And it impacts a lot of different things. And this is the part where I'm going to speed up a bit to move into kind of like the technology. But it's actually something that is very important to everybody's agenda. And everybody's talking about how do we actually transform and how are we going to move into this digital business? How are we going to change our business model, et cetera, et cetera. And it's going to impact a lot of different things. But that's usually not where companies are today. They're only facing this gap of where they want to be and where they are today. And one of the interesting things that we have the services regional manager, basically the head of consultants in the Nordics, he's out and talking to a lot of the financials. And have you heard of this Gartner thing called bimodal? And they usually talk about this journey of how do you move from this to something else. It's a transition. But he argues that it's actually something that is going to be a stack, because there's existing applications in the data center today that is driving a lot of business which has a lot of data and information. It's not like we're going to move away from that, but we're going to need to bridge something over to the new world. So what are we actually seeing that is the need to bridge? Which is a lot of different things, right? So if we look at development process, we see DevOps as one of the things that a lot of companies is interested in moving to. If we look at architecture, microservice is one of those things. I'm going to cover a bit more on the containers in the next slide, and also the infrastructure. And then the cloud here is not a public cloud. It means the consumer experience of a agile infrastructure. So it could be whatever type of infrastructure, but it needs to be API driven, it needs to be self-service, it needs to be, all these capabilities. So I think that container is quite interesting because it also impacts or how we work along all of these things, right? So if we take microservices, there is nothing around microservices that is impossible to do with a virtual machine. But let me give you an example. We have a customer that the smallest component that they run is somewhere around 200 lines of source code. If you would throw that into a virtual machine, that is like throwing a small, tiny piece of cotton into a big container, right? So the container is a better fit for microservices approach to the application architecture. So a lot of the capabilities around the container is a very good fit for microservices. They start up really, really fast. So it's easy to build elasticity into the service, and so on and so forth. What about infrastructure, right? So it's not really easy to take a local virtual machine that is running on your data center on VMware and just spin that up in the cloud. There needs to be some kind of conversion or something to move that application. Containers is a standardized packaging format which you can run everywhere. So we actually have customers that are running OpenShift as a platform in their own data centers and also on top of the public cloud because of the application requirements. So for instance, Volvo Cars, they have this global car configurator. So when you, as a customer, want to configure your new Volvo, you go to this web application and you configure the car. You want to have leather seats, you would have the coffee holder, the whatever type of stuff, right? And they want to have that experience as close to the user as possible. So they have one instance of the applications running in North America, and one in Asia, and one in their own data center in Göteborg, in Sweden. So that kind of hybrid deployment is also something that the container transforms or enables in new ways. So what about DevOps? So once again, back to Max's presentation out there, I think that one of the things that I listened to was this lean approach. So lean manufacturing, which was kind of like the codified knowledge of the Toyota production system. A lot of that is actually what DevOps is about. You can see a lot of similarities between DevOps and the lean manufacturing systems. So DevOps is a lot of practices from a software point of view. So for instance, infrastructure as code, CI/CD, a lot of things. Make sure that you, as a developer, deploy into an environment which is as production-like as possible. Again, the capabilities around the containers enforces certain behavior. Immutability, for instance. We don't change a container once we instantiate it. We need to change it at the source. So the container is really an accelerator for all of these areas, which becomes really, really interesting. Another aspect, right? So we have two parts of the organization. We have the developers and we have the operations. So to the developers, who's a developer in the room? Awesome. So we tell you guys, go out and make us different. Go out and drive the business innovation and whatever. And who's an ops guy? Who works with operation? And we tell you, oh, it better be secure. You better be within budget. And by the way, you're going to get less money next year. So how do we actually solve these two kind of clashing tasks? So operations might say, well, we need to standardize on these three components. We need to make sure that we can lifecycle, blah, 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 reducing in choice, basically, and you get angry. So container is actually very interesting because it allows us to bridge this. So we can get you to be within budget, security, compliance, and at the same time, we can allow the developer to own the content inside of the container. Look at the shipping, because it's actually very similar to shipping. If you go back a few years, they were loading like needles and hay and whatever onto the boat, which was really, it was a hassle. Throwing a couple of cows and stuff like that is going to be a total mess. So the container is really good because the one that is shipping the container doesn't need to care about what's inside. And the one that is shipping goods inside the container doesn't need to care about how the boat works. So that is what's really interesting. From a technology point of view, Linux container is really not something new, right? Does anybody know when the first source code went into the kernel to actually support the namespace? So that was the mount namespace, which was back in 2008, which is pretty old technology, right? Kind of funny. So we utilize kernel namespaces, which was also in the session before from Docker. We do use the control groups feature, which is around resource isolation. So how to make sure that one of the containers doesn't consume all of the resources to kind of like destroy the environment for the rest of them. And obviously on Linux and also Windows today, it's the Docker format that is kind of like the emerging standards. The development today is around what's called OCI, the Open Container Initiative, which makes sure that the format around the container is going to be standardized to make sure that the ecosystem around the container isn't hurt. And we also do SE Linux integration when we're talking about RedHat. So a simple comparison between a virtual machine and container, right? So what we do more or less is we strip out the part that is required to speak to any type of hardware, whether that is virtual or physical. So this is a simplification, but it should give you an idea. And why is this important? From an operational point of view, efficiency, density. So I mentioned that container is not something new. We've been running OpenShift as a product since 2012. So it's actually quite aged. Obviously, at the time, the Docker technology didn't exist, so we called them gears. It was a container. We was using a bit different technology. We called them gears. Did anybody notice? You did. Cool stuff. So have you heard of the concept kill your darlings? Yeah, so we killed our darlings. So we don't call them gears anymore. We call them containers like everybody else do, and it's basically Docker in the end. But through that time, from 2012, and we're actually making it end of life, the public version of this, we had an online version. To the online version, there was somewhere around 2 million applications deployed from 2012 up until now. Out of those, 60 to 70,000 were running concurrently. And we did that on top of 130, 140 large instances on Amazon. I'm not a math guy, so somebody could probably explain to me the density of that is, but it's absolutely huge. We do some trickery around the containers to actually reach those numbers, but the point here is that there's more to the agility and the speed of development that is applicable to containers. It has a lot of value. Another thing that I think is one of the great impacts is this. So what we're after is actually that little white dot, the application, the piece of software that is in the end delivering business value or some kind of value. It might be whatever type of application. Now, because of how we manage that application or how we package that application in the virtual machine, it has a lot of implications, right? We get a lot of stuff that we don't need and don't want. And if you stop to think about that for a while, it's actually bigger, right? So what kind of stuff do we need in the virtual machine? We need to be able to manage it. So you need to have authentication. You need to be some kind of maybe centralized logging, and it's security, antivirus, firewalls, a lot of stuff. So not only is the dots in the virtual machine impacting, but the entire data center around that is there just to be for us to be able to manage the virtual machine, out of which we actually are only interested in the application. So because we're managing the application in a virtual machine, that is driving a lot of infrastructure that we're not really interested in, because in the end, the application is what we want. So a container allows us to have a different point of view of the data center. I think that Google's guy wrote a blog post about how containers will enable you to have an application-centric view of the data center. And the implications of that is also quite large, because we might not need all of that infrastructure that we have today just because we're managing applications as we currently do with virtual machines. Okay, so finally, that was a long introduction to OpenShift. Questions so far? Everything is quite clear? That's awesome. So what is OpenShift then? So I mentioned we've had OpenShift since 2012. We had containers, we called them gears, nobody cared. And once Docker came out and everybody talked about containers, we saw that we need to jump ship, right? We need to kill our darling. So we did that. So today, when we install OpenShift, obviously it's RHEL, right? So we have RHEL in the bottom, and there's two choices of RHEL that we have. We have the traditional RedHat Enterprise Linux, which is the same stuff that you run on physical, virtual, public, private cloud, doesn't really matter. It runs everywhere. Not Power or ARM. Well, RHEL does, but OpenShift doesn't. We also have the option which is called Atomic Host. Atomic Host is just enough operating system to sustain a container. So if you would like to operate a fleet of container platforms or container hosts, Atomic Host is a very lightweight piece of software to do that. So it's very, very small. You can compare it to a hypervisor for a virtual machine, which only has the required pieces to run a virtual machine. Atomic Host does the same, but for containers. Now, on top of this, because, I mean, it's not really hard to see why Docker became so popular, right? You do Docker pull MongoDB, Docker run MongoDB, and you're up and running with a MongoDB. However, 1 is cool, 5 is better, but even more is even more awesome. So we need to have some kind of orchestration. And we choose to go together with Google. And a bit of background on Kubernetes is that Google is probably the most famous user of containers there is. Everything in Google runs in a container. So if you do a Google search, that search is actually running in a container. If you open your inbox or Google Drive, that is actually running inside of a container. If you go on Google Compute and order a virtual machine, that machine is running inside of a container. And that's pretty interesting, right? But for Google, the virtual machine is just another piece of software. It's an application. You order the application, and they deliver their applications with containers. So again, it allows you to have the application-centric view of the data center. The current versions of the orchestration layer at Google is called, I think it's called Borg, actually. So if you're a Star Trek fan, you know that resistance is futile, right? And what happened was that through the iterations, there's been a couple of iterations for the orchestration layer at Google. They choose to open source and donate Kubernetes to the Cloud Native Computing Foundation. So under the Linux Foundation, there's actually 2 projects, many projects, but those that we care about in this context is OCI, which is the Open Container Initiative, and CNCF, which is short for Cloud Native Computing Foundation. However, all of these boxes that you see on the screen here, networking, storage, registry, logs and metrics, and so on and so forth, that is actually, should we call it empty? They are not actually an implementation of that. They ship the infrastructure or the plugins to be able to interface with networking, storage, and registry, and so on and so forth. So we actually fill those when you install OpenShift, so that, for instance, networking, which will be an Open vSwitch component that does an overlay network with VXLAN, and it does segregation for the traffic on the cluster. Storage, for instance, we ship a couple of storage plugins, which allows you to write claims to consume storage, and so on and so forth. On top of this, then, we have Red Hat's version of the Oral-B Brown Control user experience. So how do we actually fit into the current development process? Because if we come to a customer and say that, oh, are you developing software this way today? You need to throw that out and do it in some different way. We cannot do that, right? So we need to be sure that we are able to fit in to whatever development process there is. But this is where we focus on stuff like self-service, service catalog. How can I actually enable the kind of this fundamental question? Which lifecycle components does the developer want access to and the operation is able to lifecycle manage? We do that through this kind of like upper layer. So that would be where you define, I want to have these frameworks like Java and whatever, a lot of stuff, storage, and so on and so forth, and that would be offered as a self-service ordering for the developer. So that is basically what OpenShift is. So from an architecture point of view, this is actually how it looks. So in the bottom, we need some kind of infrastructure, but we run wherever RHEL runs, so physical, virtual, public, private cloud doesn't really matter. The next concept is pretty interesting. So we have the service layer, right? So containers are ephemeral in nature. They come and go. So we have a service and it's backed by some kind of auto-scaling feature. Let's say they do. So currently we are having 3 containers that is backing that service. But once load goes up, we might have 10 containers of that running in production. So how do we actually find these containers? So let's have the example of we have a front end and a back end, a really simple case. The front end needs to talk to the back end to expose some kind of data or information to the user. So when we scale the back end up to more, how does the front end actually know which container to talk to? Or if we spin down, this is being taken care about the service layer. So while containers are ephemeral in nature, the service layer is not. It's a consistent point where the containers can always talk to a known and stable entity or endpoint. We have a couple of nodes in the cluster. They were used to be called minions, which is a much nicer word, but they settle on nodes. And there you see something which is called the pod. So pod is the smallest atomic unit that you can orchestrate on top of Kubernetes. And it actually comes from the view of a pod will look like a virtual machine. So you can actually run several containers inside of a pod, but they will share some of those namespaces. So for instance, they can talk to each other. Over localhost. And then we have the masters, which is the brain of the cluster. If the masters go down, we cannot introduce any change to the cluster, but the containers that are up and running will continue to do so. But those are taking care of stuff like, is the current state of the cluster in a fashion of what it's supposed to be? So we store that in something called etcd. So we store the desired state of the cluster and the current state of the cluster. And if there's any difference between that, there is a controller that drives the cluster to look the same. So an example, I've said to the cluster, I want to have 3 containers of this front end running. One of them dies. The controller will pick up on this and see I only have 2 and create another one. Now let's say there's a network partition in the cluster. So one actually goes away, so I only have 2 again. I spin up a third again, so I always have 3. And the network partition goes away, so the cluster is actually bringing the node comes back into the cluster. Then I might all of a sudden have 4 containers running. The controller will also pick up on that and, kill the container, but we're not hurting anyone here. To interface with the installation of the cluster, we have a couple of different ways of doing that. So we have an OC client, we have a web interface, and the developer would use, his or her choice of tools. So some kind of CI/CD engine or Git or something like that. Now, what we have so far is an absolutely fantastic container as a service platform, which basically means you can spin up containers. So there's no value in that, right? Well, there should be. So on top of this, we enable you to run whatever type of platform that you want. So we do package our own middleware. So everything in the RedHat JBoss family, like mobile, data grids, whatever, that's packaged as a containers, even integration. So the same kind of like way of working for a developer, like CI/CD, unit testing, and everything, is applicable to the entire middleware portfolio. So you can run the same process, even though you're running integration or rules engines or business processes. It's the same concept of a pipeline to introduce the changes into production. Obviously, we have the third parties, so ISV vendors, for instance, that can package their own applications and run on top of the platform. So I mentioned Volvo Cars, for instance, with a global car configurator that is actually running WebSphere Liberty Profile inside of the container on top of Azure. So a mix of IBM, RedHat, and Microsoft. What could possibly go wrong? An interesting thing is we're actually packaging RedHat storage inside of the platform. So you can actually have a blueprint of a data center in a box, which allows you to run on any type of infrastructure. So we can bring on storage, middleware, just about everything. Obviously, you can pull from Docker Hub as well. But as Docker guys themselves said, that those images might or might not be managed. So you need to care about what's inside of the container. And what's inside of the container is actually quite more fun. So there was a collaboration or a partnership announced a couple of, is it like almost 2 years ago? December, November 2015. Between us and Microsoft. And there was a couple of different things in that partnership agreement, but one of them was that we will support and have version parity of .NET Core and ship that as part of RHEL within 60 days. So yes, you can run .NET on Linux. .NET Core, which is not the same thing. But I mean, that's one of those moments that I actually sometimes need to pinch my arm. Is this actually happening? And yes, it's actually happening. I don't know how much you know about Red Hat and what we do. We like to claim, or we say, that we're the biggest open source company in the world. Now, a lot of people know about open source, and they think that, yeah, open source, it's a license model, right? It's a GPL, there's BSD, there's MIT, there's a bunch of different licenses. But if we're talking about open source today, sure, it's still a license model, but we like to call it an innovation model. Everybody engaged with the open source community today comes into that with the innovation in mind. If you look at a lot of the kind of like advances in the technology from the last years, like cloud, mobile, big data, all of those are actually sprung out of open source. Big data is like 3 companies, all based on open source. Mobile, Android, and so on and so forth. Social, Facebook, all of these companies that are inventing great stuff, they're doing this on the innovation model of open source. So OpenShift is the same thing, right? We invest and hire people to work in those communities. So obviously we invest in Docker. So I think that we're the second largest contributor to Docker after Docker themselves. And that's also true for Kubernetes. And then we kind of like this entire open source ecosystem, we build a new community project, which is then called OpenShift Origin. That is the community kind of like upstream version of our enterprise product. And then we have kind of like the secret sauce of Red Hat. How do we transform this innovation and give it a ecosystem, a life cycle, make sure that it's secure, there's a partner ecosystem, there's trainings, there's consulting, this other stuff that we actually care about. And then that comes out as 3 different ways of consuming OpenShift. So we have, again, the online, which is then out in the new version now, version 3, which is basically a shared service. You can go there, swipe your credit card, and you can run 5 containers or whatever you want. The dedicated one is, well, I don't want to operate it myself, but I also don't want to run on a shared service. So that is, the dedicated is then the same team that is operating the online, they will have a dedicated instance for you alone. And you will run that on top of a public cloud. Or we have the kind of like the top one, the OpenShift container platform, which is the one that you would install inside of your data center or somewhere else, wherever type of infrastructure that you want. So in a closing note, we go out today and talk to our customers, and whether it's connected to any kind of this area, so whether it's the development process, which is a lot of the engagement that we do is actually driven from this kind of, we are interested in this new way of working. Then we do that kind of like a POC or a project around OpenShift. If it's around microservices, it's around OpenShift. Containers, obviously, but also if they want to have this cloud experience, we also do that with OpenShift. And with that, we have roughly 5 minutes of questions, because that was basically what I wanted to cover today. So I'm actually on time.
Yes. So, any questions or comments, observations, comparisons?
I could ask one question. I think you were listening to the first presentation about Kubernetes. What would you say OpenShift adds on top of only Kubernetes?
Yeah. So one of the things that the former presenter mentioned is that what we're looking towards next. So one of the things was their RBAC, role-based access control. So we drive a lot of, we are open sourcing everything that we do, basically. There's no secret sauce of RedHat that we keep this ourselves. We're driving everything into the community. However, to upstream a feature into Kubernetes, that might take a while. So we might innovate around a region and then upstream that code into Kubernetes, because that usually takes time. Kubernetes has, I think it's 16 special interest groups, and I think that we lead 7 of those. So role-based access control is one of those things that we have in the product, and we are upstreaming that into Kubernetes, but that is taking a while. So that's one difference. Kubernetes, the API of Kubernetes is exposed inside of the platform. So if you want to use only Kubernetes feature, that is something that you're fully capable of doing in OpenShift. But we also add a couple of other things, right? So I mentioned there the kind of like the user experience. So how do we do deployments? How do we do rolling upgrades? How do we do A/B testing? I want to have a specific version, and just to expose that to a small fraction of my consumers, and I want to see the business impact of that change. How do we do those kind of things? So that is one of the differentiators, I would say. More questions? Yeah?
I've understood there's a version of OpenShift that you can run on your local development machine.
Yeah.
Say a couple of words about that, because I think that's really cool.
Yeah. Oh, thank you. Gold star to you. You're not working for RedHat, are you? So we have a page which is called developer.redhat.com, where you can register for free, and you can download something that is called the CDK, which stands for Container Development Kit. It is a all-in-one installation of OpenShift that you can run on top of your laptop, and it will give you the same experience that OpenShift is. And we support that, and we ship installers actually for Windows, Mac, and Linux, I think. So you can just download, if you have a Windows laptop, you basically download a executable, or MSI, I think it's called, and you double-click that, and it actually installs the entire thing for you locally, so you can develop that. There's also a couple of other things that's interesting if you want to just give it a run. Have you heard of Katacoda? So Katacoda is a service that allows you to experience things and you kind of like get a very educational awareness around a specific topic. So there's a openshift.katacoda.com, which basically in the web browser allows you to start up a cluster, log in, do some very, very basic flows, so to speak. Was that spot on? Good. We're also transitioning this, so there's something called Minishift. So the current version of CDK is built in a certain way, but the community actually picked up and helped us out there, so we're transitioning into another way of packaging this, which is going to be easier to maintain going forward.
Okay, one more question. What would you say to a guy that says that Docker plus AWS is enough?
Well, Docker and AWS is enough. Well, there's a lot of potential discussions in that. So one of the things that I would say from an orchestration point of view, I would say that Kubernetes is one, but that's my opinion, right? So there's no one with the knowledge and history of containers and orchestrating them than Google. So and that is a donated project into the Cloud Native Computing Foundation. So it's on a standards body that is going to make sure that the ecosystem isn't hurted. So I would say that's one of the important aspects. And I mean, there's always going to be vendor lock-in, always. So I cannot say that there will be no vendor lock-in from Red Hat. There's going to be some vendor lock-in. It's just about how much vendor lock-in can you afford. Now, from a technology point of view, there is no vendor lock-in on Red Hat. Everything we do is from a technology perspective, is out there. We don't keep anything ourselves. So if you would like to get out of the Red Hat experience, you can still use the technology, but leave kind of like the business relationship of Red Hat. That is not something that you could do if you too tightly integrate with the service like that. There's more things. So what's inside of the container matters. So the Linux kernel is like 30 million lines of source code. Now, would you trust someone to support you if they don't even show up on the list of the top contributors to the Linux kernel? Or if you do trust them, are you getting enough what you're paying for? Because they say, we'll support you, but we're not able to commit code upstream because we don't have any developers. Oh, we cannot take a enhancement request because we don't have any developers that can commit upstream. So I would say that those are my, first comments, but that's a long discussion. Thank you.
Oh, actually, we have still a few minutes for the discussion. So actually, I have one question.
Yeah.
So we have been discussing quite a lot about the challenges related to, in a way, or the friction, in a way, the companies have, in a way, in adopting containers. So what do you think? What are the biggest challenges or biggest friction that still we need to resolve?
Good question. So that's also a long discussion because there's many things. I don't know about you guys, but we in IT, we tend to be very passionate about our choices. So this is one challenge. So if I'm going out to the operations guys and talk to them about kind of like this is what the developers would like to consume, it could be that the people that I'm talking about, they're not called operations. They're called, for instance, VMware. And so we tend to be very, very passionate about our choices. So one of the challenges is that even though we have a very, very good solution, just because it doesn't say what the operations side actually wants for the brand, that is one challenge. The other challenge is that we use this as kind of like how do we do digital transformation? That's a long topic. That's a really long topic. And the main issue that I see is that when I come out to customers, they say, yeah, this is awesome. Yeah, let's have a meeting and formulate a strategy. I was like, no. Or even worse, let's formulate a strategy and a governance model of how to do this. Everybody knows that they need to move, but traditionally we are kind of like on how to do an implementation is that we do the waterfall approach, right? We sit down and plan for 6 months and then we do something. That is probably the biggest challenge that I see. It's actually like watching a glacier move. So because we're so unused to do this lean startup that we don't know everything, but we have a minimum viable product. Let's do that. And let's make sure that the implementation that we did it realize the business value or whatever? Did it fix the problem or whatever? And then we move on. But we're not used to doing it that way. So I'd say this is probably, the technology is not the challenge. People or how we are used to working is the biggest challenge.
Yeah, that's an interesting observation. But okay, so thank you for the interesting presentation.
Thank you. If you guys want, I can show you a demo at my booth, if you guys want. Cool.
Okay.
Thank you.